can see the test here.
No, but I believe you. No problem.
Okay.
No. I have to open my line now.
Okay.
Forse va bene.
Questi giorni amici di sciura che si toglie da 5 giorni.
Okay. Mi serve. Okay, Misa. These are 40 euros.
Okay, 40.
Yeah.
It's not.
No,
necessary.
yeah.
No,
okay.
no.
Okay, in the middle.
Okay,
Take here. I want to see these euros when
I
you.
will save it because I never saw euro.
Okay. So I want to see these euros in Napoli. So you offer me a pizza with these euros. When
Okay. I will save it because I never see euro paper
Okay.
in my life. So thank you.
No, thank you to you.
Ma non sa dove cambiarli.
No, you can change in the bank.
It's possible. I believe it's possible.
No, it's true.
Okay.
You can change.
Yes. But I will save it because I never see.
No, non è visto di carta. No, bello.
Pessimo anche trovare segretaria. Poi per fare delle vendite più corti. Questo è il titolo dell'Amazzone e questo attorno non so cosa sia. Prendi da io.
Poi ci distanziamo, grazie, grande. Bello, no? E vai.
Okay, Marcelo sent me an email and he told me congratulations for the course because it was very good.
Great.
Okay, we will have
5 minutes, 10 minutes, 10 minutes.
5 or 10 minutes to wait everyone.
Yeah. And then with Della, we have some ideas to continue our works.
Yes.
And if you and Stefano wants to continue after the PhD, you can spend, I don't know, 4 months, 6 months in Napoli, and we can months. Yeah, too much?
Good. No, it's very good.
Okay.
It's possible, Domenico, to get
Money?
money.
I believe that I have to understand with Della Mano, because we have to create this collaboration.
Yes.
And after we create the collaboration, we can ask for money for you and Stefano.
Yes.
And we can. It's good because with you, we can continue on
PDD.
oh,
The research.
Research.
Not research.
research.
Yes, I want to finish my PDD.
Yeah.
So, but I talked with the Amaro before you came here, because I wish to finish my PDD, but if Dela thinks necessary to do more something, okay, I can do.
Yes, but you need some money after. Okay, so we have to find some financial. I don't know.
Yes, because I have a lot of fear to go to defense, and in defense, any shit happens.
No, I believe that if we finish, we have to work this month on the paper.
Yeah.
A lot.
Yes.
This month we have to finish the paper. So you have to work. Don't be stressed, and you have only to think to the paper.
Okay.
Yeah.
Okay. Yeah. Okay, just a moment.
Yes. We have 5 minutes. Che dicono dal corso? Nessun'altra cosa. Hello, sir.
Juno said that he will not come today because he will have an appointment with his advisor. I sent you the form.
Yes, I saw. Thank you.
Still, I talked with Amaro this morning, and I know we have some idea on how to continue your work and work on Misal after your PhD. So with the Misal, we want to, regarding the work of Misal, we want to continue to work on the metamorphic testing. And since I talked with Dylan, I started last year with a couple of theses on the testing on extended realities of the system. I have a thesis that is divided in two parts. The first part is a sort of literature review on the architecture that are used for implementing this kind of systems.
I wrote some papers about that.
Yeah, but then maybe we can extrapolate this part of the thesis and try to submit it because it's a good point. And then we have a reverse engineering tool where applying static analysis to Unity, source code is able to build the graph of the application. And it could be used as an example if you wanted to start something on the testing. With the data, we're trying to, when I return in Italy, I try to create a sort of collaboration in order to find some fund that can support you, MISA, or both to come in Napoli and to stay for 6 months, 1 year, on the time that you want to stay. So these are our plan with data. It depends by you now. If you want to collaborate, if you want to continue, it's up to you.
Let's discuss that. Can you send me the thesis that you are talking about?
Sure. I sent you. I don't know if you can send me also your WhatsApp. I sent you the thesis to you and Della on Monday or Friday when I get
No problem. Take your time.
Yeah.
Okay, let's start.
Yeah. So finish. Just a moment. I need the pointer.
Okay.
Just a moment, Misa. After to present the link.
Okay.
I have to appear, or at the end of this hour, I can say goodbye to everything and say that at 3:10 they have the meeting. But I said they had the test. What do you think?
I think you don't need to stay in the room.
Yeah. So I finish the class at
Yeah.
3 as an example. I say goodbye to everything, and I say okay. At 3:10 you have the meeting. You have the test to finish in 50 minutes. Okay.
Okay, now you can talk about the beginning of class. Okay, let's start.
Yeah. Okay. Good afternoon. Good afternoon, everybody. We are here for the last hour of this course. I would also remember you that at 3:10 we start the test for this course, and the test finish at 4. Okay, so you have 50 minutes to finish your test. You will have the link to the form where you have to compile your test, and good luck, and we can discuss at the end of this lesson. Okay, let's start with the presentation. Okay, in this hour I will present you some results or some insight about this new topic, this new trend, that is the artificial intelligence that is applied to GUI testing or to GUI-based testing. Regarding the definition of artificial intelligence, there are many definitions. For the scope of this course, I decided to use the following definition. Artificial intelligence is a generic term that refers to any machine or algorithm that is capable of observing its environment, learning, and based on the knowledge and experience gained, taking intelligent action or proposing decisions. There are many technologies that fall under this broad definition of AI, and at the moment, machine learning techniques are the most widely used. Okay, if you see here, I conducted a tertiary study with some of my colleagues, Brazilian and Italian colleagues. No, Santiago is from Uruguay, but now he works in Scotland, in UK. And we conducted this tertiary study on the use of artificial intelligence applied to software testing. We submitted this work to ICMC Computing Survey. It's under review, and pray for me that it will be accepted, so you can see many other information in the future. Okay. Some observation or some findings that we understood from this tertiary study. We observed that AI methodologies and techniques have around more 50 years, and we observed that the first paper where AI was applied to software testing dates in 1994. So in 1994, we found the first paper where artificial intelligence has been applied to software testing. Is why we observed that artificial intelligence has increased in this period, or in this century, in these 50 years, since we had a lot of advances in computers and resources, and we have a lot of data now that we can analyze, and then from which we can build our knowledge. So, as we know, AI nowadays is applied in many fields. So I believe that also in our mobile phones, we have image recognition software, we have artificial robots that help us in our daily life, and usually academic and practitioners from industry apply or have introduced artificial intelligence to solve typical or traditional problems of engineering. So we observed, I don't know if you read some about this, artificial intelligence now has been applied to software engineering. So, and since ST, software testing, is an area of software engineering, AI nowadays is applied also to improve the quality of software testing processes. Since the software has become more and more pervasive, and we found software in each everyday life activities, since the software is more complex, it gains new challenges for software testing. And AI can be a technique or a methodology or an help for the software engineering working both in academia and in industry. And from this study, we observed that several papers have been proposed and explored the interplay between AI and software testing. So, the combination between these two fields is very huge, we report in this slide only few examples of where AI can be applied in group-based testing. As an example, we have robots for testing the GUI of application in real environments. If you can see here, it's a robot from Fraunhofer, and I took this image from this link in order to there to the right of the picture. But it's only a solution. You can see other. You can have other brands or other products implementing this. In order to test the real GUI interface in a real device that could be also an embedded device, you have a robot that mimic the gesture of the human. The robot has an arm with a finger, as an example, and the robot is equipped with a webcam that recognizes the GUI, and he has a test case that should be executed by using the webcam and the arm. Okay, how the test case is implemented? It's another problem. It's a problem that we learned in this lesson, in this course. The test case can be generated by script, by capture and replay, by model-based, or the robot can explore the graphical user interface of the application under test. So the robot is a solution where it applies a artificial intelligence or one or more artificial intelligence techniques. Other example that I observed is the use of image recognition techniques. As an example, we need image recognition for implementing oracles in order to check whether the graphical user interface that is rendered on the screen is the one that is expected by the test case, or by interacting with the GUI. As an example, if in our test case we need to interact with specific objects, and in this case, guys, we are talking about visual GUI testing, not widget-based testing. We need image recognition techniques for recognize by applying image recognition algorithm the widgets that are rendered on the GUI, and we can use these kind of techniques for interacting with them. Okay, guys, here I wrote start learning strategies. I wrote start learning strategy because on this point, if you want to collaborate with me, we can see it opens a world. Because I observed that now we have machine learning techniques, we have reinforcement learning techniques, we have supervised learning techniques, we have unsupervised learning techniques that has been adopted during the GUI exploration. If you remember the last two lessons where I presented you the GUI exploration technique, where a robot automatically infer the model of application under test and tries to explore it as much as possible, at the moment, the only algorithm that we have is the one that I presented you, sorry, that we have, but that I presented you, is the algorithm that describes the GUI and tries to understand if the current GUI is equivalent to one of the GUIs that have been encountered before. Using AI testing technique, this exploration could be aided, could be improved by using, as an example, a reinforcement learning technique or a machine learning technique. Okay. In particular, the GUI exploration. When I talk about GUI exploration, I'm talking about online testing techniques, the ones that I presented in day 3 and 4. Okay. Another topic that I observed is the usage of natural language processing technique for aiding the definition of textual input values at runtime. As an example, imagine that imagine that you have this GUI. And you have two text fields, where insert text. What is the text that you insert here? We don't know. But if I add here a label that is user or password, we may use another language processing technique in order to understand the meaning of the label and the meaning of the text box that are near to the labels. Imagine that we have the same structure, and instead of having user and password, I have name and surname. Now, the meaningful of the two text boxes changes. And I can use, and I saw, and we observed in this work of tertiary study, that this technique, the techniques of natural language processes, can be used for aiding the definition of textual values during the GUI exploration or during the definition of test cases. Okay, but this is a rule. There are only few examples of AI, and this lesson is not exhaustive because, as we observed in this paper, the application of AI software testing is very huge. And each one of these can be a research activity. Actually, I'm working on this one, and I'm trying to understand something about this one. So if you are working on these two topics, you can contact me if you want to collaborate. Okay, now, in this 30 minutes, I will present you my experience in the application of machine learning to GUI-based online testing technique. Okay, I start from the tool. The tool is called Jugular, and it is an hybrid GUI exploration technique that combines automatic GUI exploration with the capture and replay. And the combination is aided by machine learning. The machine learning is the point that combines GUI exploration and capture and replay. So, what does Jugular? Jugular is automatically able to detect gate GUIs. And the next slide, I give you a definition of gate GUI. During the exploration of the navigation. So imagine that you explore the application, and by exploiting the machine learning, the tool is able to recognize specific graphical user interface that in this paper we define it as gate GUI. The tool is able, the approach from this point of the course, I'm talking about Jugular, and for Jugular I intend both the approach and the tool that I developed. And for unlocking the GUI, the tool asks the app for you to use it only the first time that it encounters the gate GUI. If you want to try Jugular, at the moment the tool is not open source. We are trying in Napoli to make it open source. But in this period, if you want to have a trial of the Jugular, you can contact me. It's free. You can use it, but at the moment you should contact me by email. You will find all my contacts at the end of this slide. Okay. So what is a Git GUI? Git GUIs are graphical user interface that need to be solicited by specific user input events sequences to allow the exploration of parts of the app that cannot be reached otherwise. In the next slide, I will present you some examples. So, another definition, the action of providing the specific event sequence that are needed to overcome a Git GUI is named as the activity of unlocking the Git GUI. So imagine that you have a gate, you have to perform specific cache action to unlock the gate. Okay, which are the Git GUI in modern software? We have a great number of Git GUIs. As an example, a login GUI is a Git GUI. Why the login is a Git GUI? The login is a Git GUI because you have to know which are the credentials of the user in order to unlock the Git GUI. And this is what I used with Misao in order to improve the metamorphic testing approach in order to generate test cases involving logging Git GUI. Settings Git GUIs. Imagine that you have an application. You have to go to the settings of the application in order to overcome this GUI and to use the application. As an example, if you consider a mail application, an application that you have to use for receiving or sending emails, you have to configure that application. You have to insert the link of the inbox server, or the link to the POP server, or the link of the SMTP server. If you do not insert this kind of input, of settings, you cannot use the application. The application does not work. So I need this knowledge of the application. QR code is another Git GUI. As an example, if I have an application where you have to point your camera to QR code, you have this Git GUI, because if you do not overcome this Git GUI, you cannot use the application. As an example, WhatsApp or Telegram. If you want to use WhatsApp or Telegram on your desktop, you have to point with your phone a QR code. Otherwise, the application does not work. It is a Git GUI. So, this problem of Git GUIs are not only a well-known problem in the automatic exploration, but also this is an open problem in the app network traffic signature. There are another research activity where the researcher wants to sign the network traffic. And you can have a meaningful network traffic only after that you overcome when you unlock a Git GUI. As an example, if we want to sign the traffic of Twitter, or the traffic of Instagram, or the traffic of WhatsApp or Telegram, I have to overcome or to unlock the Git GUI of the login, because only in this way I can generate meaningful traffic over the network. And there are other vendors that have this problem, like Palo Alto Networks, Dell, HP, Sophos, Mobile Iron, and so on. Okay? They have want to try to understand the app activities. So this is an example of Get GUI. As an example, Twitter. Twitter has the login Get GUI. So if you try to automatically navigate this application, you cannot unlock this Get GUI until you do not insert here the correct login and password. This is an open Android application that is Transistor. It is a podcast tool, so you can listen the podcast using this application. This is a Get GUI. Why? Because if you do not have a valid URL of a podcast, you cannot unlock this GUI. It's like a setting GUI. Okay? Okay. This is Twitter. If you run a tool that performs an online testing technique, so the tool tries to explore the application. This is the DATG, that is the Direct Activity Transition Graph. Each node is an activity of the application, that is a screen of the application under test. If you see, in this case, I run a monkey for 10 or 11, I don't remember, a lot of events. If you see, most of the times, the robot stays in the login activity. If they jump to the start activity, then it goes to the login activity and stays. Then jump to other activities. If the robot stays in this activity for a long time, it starts from the scratch. Okay. Now, what is the get activity here? The next activity in this application is the login activity. Okay, what happens when I unlock the login activity? What happens when I enter in the application? You can see that I have an explosion of the states. So if you see, I can explore the full application, or I can explore at least most of the states of the application. As a consequence of this application, I have more code coverage. I have more traffic that is generated. I have more probability to find the crashes into the application. This is the example of transistor. If you see, if I go into the main activity, this is the unlocking GUI, okay? Sorry, this is the get GUI, because I have to put here the URL of a valid podcast, okay? So when I unlock this GUI, I open the application, and the robot explores this other state. This is a very simple application, but also in this case, I have to explore the other states that are outside of the get GUI. Now we have two problems, two issues. How to recognize the get GUIs at runtime, and to provide the sequences of events to unlocking this get GUI at runtime. So, some of the approaches that were presented in literature rely on a previous configuration of the tool that is done programmatically. In the sense, if you consider tools like mine tools, that is Android Reaper, or other tools presented in literature, you have to manually configure the tool in order to say, okay, when you see these widgets, you can you have to perform this kind, or to trigger these activity, these events. Okay, so it should be done programmatically, but if I program, I waste your time, it could be error prone. So I would try to do it in automated way. And what is another problem? Then the problem is that when you perform a preliminary configuration, you need a deep a priori knowledge of the application, because you need to know which are the triggers, which are the widgets on which you have to interact, how you have to interact with the widgets. So this is another issue. Okay, this is our approach. This is the approach that is proposed by Injura. Okay, we launch the application. Okay, so we take a current description of the GUI. We have the description of the GUI that appears on the screen. Then we apply a model-based gate GUI detection. Okay, so if the current GUI is a get GUI, then we use a capture and replay approach for unlocking the get GUI. Otherwise, I continue with the classical exploration. That is the algorithm that we observed, or that we decided in the previous classes. Okay, and at the end, I evaluate the termination condition. Okay, now we have to understand how these two activities works. Okay, so during the app exploring, and when this is the state chart that describes the behavior of the unlocking. The basic idea is this one. If the tool of the approach finds the get GUI for the first time, it asks to the user to interact with the get GUI. And the sequences of events that are applied by the user or by the tester for unlocking the get GUI are stored. Then, if you see here, I go in this state. And at the end of the state, the capture is concluded, and I can continue with the app exploring. After that I finish the capture phase, each time the tool finds the same get GUI, the sequence of events that were stored, is executed. So if you see, we are combining three approaches. We are combining app exploration. We are combining an online testing strategy with a capture and replay strategy through a machine learning approach. This is the platform. Okay, this is the structure of the tool, if you ask me the tool. I have the user that interacts with the Android device. The tool works both on emulated device and on a real device. And the user has also a user terminal. So the user terminal is used to send the jugular commands like start the exploration, give me the testing results, and so on. Okay. So we have four components. We have a bridge, okay, that interacts with the App Explorer and with the Get GUI unlocker. So the Get GUI unlocker is responsible to perform the capture and replay. And the Get GUI detector is actually the machine learning component that implements the technique for recognizing Get GUI. Okay, so this is, you can see also the flow. If I have a Get GUI notification, the user has only to unlock the Get GUI. So imagine that on the terminal, you have, okay, I encountered the Get GUI, the user, meanwhile, is doing something else, have only to interact with the application, and then the exploration can go on. So we had to solve the capture replay problem because all the tools that perform capture replay, we were not able to introduce those tools in our platform. So what we did what I did with the two postdoc and a PhD student was to implement my Get GUI unlocker. So we implemented our capture and replay tool. Okay. We performed a reverse engineering of the low level of the kernel level events that are triggered when you when you interact with the screen of the device. As an example, here you see the timestamp. Okay. Here you see here the kernel events. Okay. We had to group the kernel events in the first level events. This sequence of low level events are press. This sequence of low level events is the release. Okay, what we observed that if there is a delay between the press and release that is less than 500 milliseconds, it's a tap. If we have a delay that is greater than 500 milliseconds, it's a long tap. If we want a scroll or a swipe is made by a sequence of press and release that is intercepted with one or more move low-level events. So if you see press, move, and release, this is a scroll. So if you see, this was our work. We reverse engineered the consecutive low-level events. So we captured in a log our execution. We reverse engineered the kernel level events, and we had to abstract or infer the first level events and the user events. So this is a user events. So these are the events that you perform on your mobile phone. The user events is transformed in first level events, and all the first level events are transformed in kernel level events. Okay? And how to re-execute? This is a sequence of events that we capture. This is the sequence of events that we have to execute. We defined, okay, from this one, we removed the timestamp, and we defined an our language for executing the event. As an example, we have a start and end, and it is a sequence. It means that this is a sequence of events. We have send event. After send event, I have the sequence of low-level events, and then I use a sleep. Why we use a sleep? In order to give the time to the system to answer or to interact or to finish the interaction with the after the triggering of the event. Okay. If you see here, I have a transformation of tap, long tap, scroll, and press KO. You have this sequence of captured event in this sequence of executable events. Okay?
Okay.
Yeah.
How to define the sleep?
How to define the sleep? Okay, we defined the sleep empirically. Okay, we defined 1 second and half, because in our experiment 1 second and half was sufficient for an event to finish its elaboration. There is not how to say? No, there is not a magical number of sleep. Okay, between one event and another event, you can define a good timing duration between or sleep time between one event and another event. Another observation, guys, if you see here, we had a sleep of 600 seconds. Why? Because this is a press and then release. Okay, so I have a sequence of press or release without a sleep is a tap. And what I said here, that a long tap is composed by a sequence of press and release between which there is a delay greater or equal to 500 milliseconds. Here, this is a press, this is a release. We added a sleep of 600 seconds in order to generate, or in order to make this sequence of events like a long tap. If we had here 4,000, this sequence of events is a tap, because the sleep between press and release is less than 500 of seconds or milliseconds. Yeah.
Just of curiosity, in the kernel events are the components that are the kernel events can identify the components that are interacted in the action. For example, you are tapping something in that list of events. The component is identified.
No, you have only the coordinates.
Okay.
You have the coordinates.
There are the coordinates.
Yeah, these are the coordinates where you talk.
Okay.
Okay, very quickly, because now we have only 10 minutes because before your test. We decided to adopt a machine learning approach to train a supervised classifier to determine if the GUI that we are considering is a get GUI or not. This is our process. We trained and then we implemented a classifier that perform a prediction. Okay, we started. We had to extract the feature of a GUI, and we decided to apply a feature extraction based on the textual description of a GUI. So for each GUI, we extracted the XML representation, and we among all the components object properties, we considered only the objects containing a textual information, because we assume that description of a GUI belonging to the same GUI class are usually they share the common textual information. Okay. And we select a feature as the presence or the absence of such keywords. Okay. As an example, what we say that usually in login activity we have the keywords like forgot, login, password, or Facebook. Okay. As an example, if you can see here, these are the two login activities of Instagram and which is this one. Google, okay, and this is the one of the GUI of maybe this is Snapchat, yeah. Okay, if you can see that applying this approach, we recognize the two login GUI, and we discarded this graphical user interface. Okay. This is the machine learning approach. We collected many applications from the Apple Store. I believe that we collected 5,000 of real application, and we used 100 computer engineering master students in Napoli. Each student, we asked each student to explore the selected app manually, and to label the GUI with one of the classes that we decided to analyze. And the classes that we analyzed were classified as login, settings, and others. So we were interested only to characterize these two types of get GUIs. Okay, we implemented a GUI labeler desktop application, and that is this one. Okay, if you see, this is the GUI labeler. Each time during the exploration, manual exploration, if the student found this graphical user interface, the student had only to use this select box to choose the label. In this case, the student, as an example, labeled this GUI as a login, and then he had to click on capture. Okay. So, and the tool it was used to label and assign a description or a label, to each GUI. So automatically the tool extracts the XML, and to that XML the tool adds a label according to the selection of the student. So then we had a the keyword extraction. So we used the keyword extraction to have a set of keywords for each gateway class, starting from the gateway description and their labels. And okay, we have two. We defined we divided in the set in two groups. The J1 group was submitted to a keyword extraction, and the other was used for training the classifier. At the end, we had the classifier that we included in this component. That is the gateway directly. Okay. Okay. This is my experience with the AI, and these are my contact. If you want to have other, if you have some doubts, okay, this is Napoli. If you want to visit me, we can. This is the view of the Gulf of Napoli. And if you want to contact me, you can find me on Skype. This is my Skype ID, or you can contact me on Gmail. So you have to write my surname and the name. And this is my mail at the university. That is domenico.amalfitano@unina.it. Okay. It was a very pleasure for me. I know there are questions.
No questions.
Okay. It was a very pleasure for me to stay here. I very hope that you liked the course. It is not an exhaustive course. I tried to give you some pointers and some practical pointers to the main techniques that are used for the GUI testing and the GUI basic testing. In this last lesson, I liked to show you which are the future, maybe the future research direction in testing. That is the application of AI methodologies in software testing. And I said to you before, this is now one of my main research activities. So if you want to join with me, it would be very a pleasure for me to interact with you in these topics. Okay, I leave you, and I would only remember that at 3:10 you have the test, and at 3:10 you have the 50 minutes to finish the test. Mission, you sent the link to the students?
Yes, I will send now.
Okay. Okay. Now, Misal is sending you the link, and the link opens at 3:10, right?
Yes.
Okay. I want to say goodbye to all.
Yes.
Okay.
Okay, I sent the link.
Okay. You see the link. Okay. Thank you again, guys. See you in some conferences online. Okay. Bye bye.